Hello.
Hello. So, in our previous class, we have discussed about transition curves, and basically, up to the transition curve that finish the horizontal alignment portion. Okay, so from geometrical design chapter, uh, right now we have completed side distance elements and horizontal alignment details. Now, the next portion is vertical alignment. So basically, if we review our previous classes, basically side distance considerations is applicable for the visibility ahead of the driver, and horizontal alignment is basically the horizontal profile of a highway, and that includes the horizontal curve, transition curve, extra widening, super elevation, etc. Now, in the vertical alignment details, we will get to know about gradients, okay, and summit curves and hilly curves, etc. So, the vertical alignment is the elevation or profile of the central line of the road. Okay, so basically that is the elevation of the road. Okay, for this reason, it is called vertical alignment. Now, the vertical alignment consists of grades and vertical curves. So, there are two types of things. One is grades, and another one is vertical curves. And if you can see this picture, so in this picture, see the vertical profile of the road. Okay, there may be different undulation, ups and downs. So basically, that are called vertical alignment. Now, this vertical alignment of a highway influences different factors. So, what are these factors? First one is vehicle speed, okay, acceleration and deceleration, side distance, vehicle operation cost, comfort while traveling at a high speed. Now, how this is influenced? So, for this reason, see this picture. Whenever that is a up uphill, in that case, the vehicle speed will be reduced, and that acceleration would also be reduced. But, but whenever a vehicle is going downward, in that case, speed may be increased and the rate of deceleration will also decrease. Now, for the side distance, if it is a summit curve like that, in that case, there may be a hindrance in the visibility. Okay, so this way is all these parameters are affected by the vertical profile of the road or vertical profiling of the road. Now, from the vertical profiling or vertical alignment, the first one is gradient. Okay, so gradient basically is a minor undulations over the road. Okay, so gradient is the rate of rise or fall along the length of the road with respect to the horizontal. Okay, these are the undulations, minor undulations. So it is expressed as a ratio of 1 in n, or it can also be expressed as percentage. So there are four categories of the gradient: ruling gradient, limiting gradient, exceptional gradient, and minimum gradient. So basically the concept of gradient is the rate of rise or fall, okay, during the entire section of the road or entire portion of the road. Now, based on the up or down, there are different types of gradient: ruling gradient, limiting, exceptional, and minimum gradient. So, ruling gradient is the maximum gradient using which a designer attempts to design the vertical profile of the road. So, basically, it is the maximum gradient which you can allow as a designer. So, if you are a designer, in that case, whenever you are going for a vertical profiling of a road, you need to see for the ruling gradient from the code book. Okay, and based on the ruling gradient, you will decide about the cut and fill of your entire embankment section, and as well as you will decide for the vertical profiling of the road. Now, this ruling gradient, there are different factors on which this gradient will depend on. That
Sir,
is, yes,
so can you explain again that gradient?
okay, gradient. Okay, so gradient is nothing but the rise and fall along the section of the road. Rise and falls means down or up. Okay, like that. So basically, that is rise and fall along the length of the road with respect to the horizontal. Suppose if you consider this section and if you consider a horizontal portion, in that case, see here some down portion is there, some up portion is there, then again some up portion is there over there. Okay, so this type of things is called gradient. That is the undulations over the road or rate of rise or rate of fall. So this is gradient, basically the vertical profile of the road. And the difference between gradient and vertical curves is that vertical curves are much more steeper than the gradients. Okay, so basically these are some minor changes over the elevation of the road. So whenever you are trying to design any road, so there are different type of gradient, and based on the gradient, you will try to choose whichever gradient is applicable for you. Suppose for the hilly areas, suppose some specification for the ruling gradient is given as 1 in 100, suppose. So 1 in 100 means you cannot go a 1 mm distance within a 100 mm horizontal distance. So your maximum vertical profile would be 1 millimeter with respect to 100 millimeter horizontal, or 1 meter vertical with respect to 100 meter horizontal. So based on this, you need to cut and fill your entire embankment section. So in the hilly area, sometimes we have seen that uh, the the roads are very much curves are there. Okay, there are different curves are there, and if you can look from the above, you can just think that why that road are going that in this zigzag motion. Why we cannot just connect all this point and make it a straight path? Okay, sometimes you may have some such questions, but that type of construction or that type of zigzag roads have been constructed to accommodate that gradient within that road. Okay, that is whatever gradient is applicable over there, you need to imply that over that road. So for that reason, the zigzag road has been coming up in the hilly areas. Okay, is it clear?
So, sir, so what is the difference between its gradient and chamber? Chamber
Yes.
is also the cross
Camber,
section
camber,
because
camber.
yes, sir.
See, gradient is if you are considering the vertical profile, vertically. Suppose you are going in the direction, in the straight direction. Okay, so in the straight direction, suppose for that picture, okay, so there are some undulation over the length of the road. So that is gradient. And whenever you are considering about the camber, camber is the see. If you consider in that lateral direction, okay, so that curve is basically in the lateral direction. So the gradient will be in the horizontal direction, that is the undulation in the horizontal direction, and camber is the slope in the lateral direction. That is the difference between camber and your vertical alignment. That is gradient. Are you getting my point?
Yes, sir.
So if this is a particular cross section, okay, of the road, so basically camber is in the lateral direction, in this direction, okay, within the width of the road, but your gradient is in the length of the road, okay, that spread over the length of the road. So basically that is the difference between gradient and camber. For example, suppose you are going from Naringi to your college university. Okay, so if you are going from Naringi to university, mm, suppose you have crossed that Panikhete police station. After that, you have to enter the university zone. So whenever you are entering a university zone, that portion is hilly area. Okay, so you have to go up. You have to go up, and then your university is situated over the hilltop. Basically that portion of the road have that gradient, okay, and that is a mountainous gradient over there. So gradient means that you are going upward, but within that road, that central portion of the road would be somewhat at a higher elevation than the side portion. Okay, so that portion is basically camber. So camber is within a particular section, whether the top portion or the crown portion of the pavement is raised above the side portions. Okay, that is camber, but your gradient will be throughout the entire road, and that is because of the differential elevation of the entire area. Is it clear?
Yes, sir.
Okay. So basically, ruling gradient is the maximum gradient which you can allowed over the road. Okay. Now, for the selection of the road, there are different types of factors which affect the ruling gradient, like type of terrain, length of the grade, speed, pulling power of the vehicle, etc. Now, if we consider about the different terrain, so for the plain and rolling terrain, the ruling gradient is limited as 1 in 30. Like as for mountainous and steep having elevation more than 3000 meter above, here the ruling gradient is fixed as 1 in 20, and for the mountainous and steep having elevation more than 3000 meter above the mean sea level, there your ruling gradient is 6%. Okay, so if your area is plain area, in that case, whatever gradient you have to design, that gradient is 1 in 30. If your area is mountainous area with elevation, uh, with having a steep elevation, in that case it would be 5%, and if it is mountainous with more than 3000 meter above MSL, in that case your ruling gradient would be 6%. So based on this ruling gradient limiting value, you have to design your entire section. Okay. Now next thing is limiting gradient. Now limiting gradient is steeper than the ruling gradient. In some cases, in some hilly areas, what happens? Suppose for the mountainous areas, you have to provide F5% if you can go with ruling gradient. But suppose in the site condition there is not enough space to provide for that 5% elevation. Okay, now you have to go for the limiting gradient for that particular section. For that, suppose that 100-meter section is there, for only for that particular section, you can apply for the limiting gradient whenever you do not have any way. Okay, or whenever you do not have any land available over that area. Now see the difference. Here it is 1 in 20, and here it is 1 in 16.7. So difference is here you can go up 1 meter within a 20-meter horizontal section, but here you can go up of an elevation of 1 meter within 60.7 meter of horizontal distance. So here for the second case, for the limiting gradiency, the horizontal distance covered is lesser, so that gradient is basically steeper than the ruling gradient. So for this reason here, the length required, or the portion of the road section required to go up to a particular elevation is lesser than the ruling gradient. So for this reason, whenever your area is restricted, or you have some space constraint or some other problems which cannot allow you to provide the ruling gradient, you can go for the limiting gradient. Okay. The next portion is exceptional gradient. So exceptional gradient are very steeper gradient, and they are provided in a unavoidable situation where limiting gradient can also not be provided. But one thing is there, whenever you are providing the exceptional gradient, that stretches with exceptional gradient should not be more than 100 meter at a stretch. Okay, it should not be 100 meter at a more than 100 meter at a stretch. That means suppose you are considering for the exceptional gradient for a road section. So suppose that road section is 90 meters, so you cannot go by the 100 meter. After that, you have to provide some flat area or some downstream area. After that, again you can provide the exceptional gradient of up to 100 meter. Now this concept is clear. What is ruling gradient, what is limiting gradient, and what is exceptional gradient. Okay, now another type of gradient is there, that is called minimum gradient, and this minimum gradient is provided to drain of the surface water. Okay, so it is important only at location where surface drainage is important. So basically for the surface drainage, basically in the hilly areas and tropical region, that minimum gradient is important, because in that areas there will be different cross drainage structures, and rainfall within that area would be very much higher. Okay, so for this reason there will be problem of surface drainage, and that surface drainage should be drained off from the uh, pavement surface. Okay, so for this reason, if that portion, tropical area portion, falls in plain terrain, in that case you need to provide some minimum gradient over that area, so that the surface drainage can be surface water can be easily drained off. Now, this camber will take care of the lateral drainage, but the longitudinal drainage along the side drains requires some slopes for the smooth flow of the water. Now, consider this situation as any of the highway within your area. So, in the highway, there are drains adjacent to the road. Okay, now with the help of the camber, all the water from the top most portion of the pavement will be get drained off and would be accumulated in the side drains. Now, if there is no slope in the side drains, in that case, water cannot pass through it. Okay, to enable the water to pass through the drain, we need to make some elevation within the drain, and that elevation should be maintained over the road surface also. So that is called minimum gradient. So basically minimum gradient is provided for the drainage purpose whenever other type of gradient is not required. Okay, suppose one plain area is there and there no type of gradient is required. So in that case, you have to intentionally provide the minimum gradient to drain off the surface water. Okay. Now next question is grade compensation. So from this name, you can just get an idea about this. That is, we are compensating grade for some other process. Now, what are these other causes? Suppose whenever a sharp horizontal curve has to be introduced on a road which has already maximum permissible gradient. Suppose in the hilly area, okay, in that hilly area, some steep horizontal curve is there, and the nature of the horizontal curve is it is also going in the upward direction. So there are two types of things within that portion of the road. That is, the horizontal curve is already there, and that portion have a steeper gradient. That is the maximum allowable gradient over there. So if this two type of action is presented over a particular section of the road, in that case, it will create very much hurdle for the vehicles to overcome that section. So for this reason, whenever a steep horizontal curve is there, in that case, the gradient over there is slightly compensate to accommodate the different type of vehicles. Suppose, suppose for example, in a horizontal curve, uh, that your maximum allowable gradient is there. Suppose a gradient of 1 in 16.5 is provided over there. Now the thing is, as it is already a horizontal curve and already a maximum gradient is provided over there, so in that case it will create some problem for the vehicles. So for this reason, that maximum gradient, suppose 1 in 16.3, which you have allowed over there, that maximum gradient is reduced with some percentage values. Suppose it reduced to 1 in 20 or 1 in 25, like that. Okay, so that different vehicles can easily get uh, get over it. Okay, so this type of thing is called grade compensation, because for the sake of horizontal curve you are compensating the grades over there, that is the maximum grade over there. Now, as per the IRC guidelines, this grade compensation is not required for grades flatter than 4%. So, if your grade is flatter than 4%, in that case, grade compensation is not required, and the maximum grade compensation is limited to 75 divided by R percentage. 75 divided by R, where R is the radius of the curve. So 75 divided by R percentage, that is the maximum value of the grade compensation which you can allow over there. Now, next question is effect of gradient. Now, the effect of long steep gradient on the vehicular speed is considerable. So this is particularly important in roads where proportion of heavy vehicle is significant. So in such cases, the effect of long steep gradient is very much effective, because that will reduce the speed of the vehicle. And if there are particularly heavy vehicles are moving over there, then it will affect the vehicles very much, and due to that excessive load and excessive gradient, sometimes the vehicle axle may broke down. Now, due to another thing is due to restrictive side distance at uphill gradient, the speed of the traffic is often controlled by these heavy vehicles. Because in the hilly areas, suppose you are driving and suddenly you find out a truck in front of you, you cannot cross it because your side distance would be hindered because of the different gradients and horizontal curves present in the hilly areas. So for this reason, in maximum cases, these heavy vehicles will dominate or control the speed of the other vehicles within that hilly areas. Okay, now as a result, not only the operating cost of the vehicles are increased, but also capacity of the road will have to be reduced. And for this high differential speed between heavy and light vehicles and between uphill and downhill gradients, accidents may happen. So these are the effect of gradient, and these effect of gradients are mainly uh, very much prominent in the hilly areas. So next question is how we represent the gradient. Suppose there is a gradient. Now how you measure the gradient or how you represent the gradient, whether it is the uphill gradient or downhill gradient. What is the percentage of that gradient like that? Now here the positive gradient or ascending gradient which is going upward is denoted as plus n and the negative gradient as minus n. Now the deviation angle is n. Now when two gradients meet, the angle which measures the change of direction and is given by the algebraic difference between the two grids, that is n1 and n2, like that. Suppose for example, now coming to the vertical curves. So within that vertical curves, I will give you one explanation about this representation of the gradient. So first thing is whenever vertical curve is necessary. Vertical curve is necessary when two types of gradient will meet each other. Suppose for example A, okay, in the picture a positive gradient of plus n1 and another positive gradient of plus n2 will meet each other. So in that case, you need to accommodate the vehicle from n1 to n2. So for this reason, you have to draw a vertical curve. Okay, so basically this is your vertical curve. Now you will denote the deviation angle. Deviation angle means the angle subtracted by the two gradients. So that gradient is n and it is denoted as deviation angle. Deviation angle is basically the difference between two gradients. So here it was positive n1 and here it was positive n2%. So your deviation angle is n1 minus n2, like that. Okay. Now for the another example, suppose this is a positive gradient plus n1. Okay, meet with zero level. Zero level means that portion of the road doesn't have any gradient. So in that case also a horizontal curve is required and your deviation angle would be n equal to n1 minus 0, that is n1. For third one, here see, here one positive gradient and another negative gradient will meet each other. So here your deviation angle will be plus n1 minus of n2. So that is n1 plus n2. Now if first one is minus and second one is also minus, in that case it would be minus n1 minus of n2, that is n2 minus n1. Okay, so these are the cases how you can explain the deviation angle, and basically this is the concept of vertical curves. When vertical curves are required. So vertical curves are required when two types of gradient will meet each other. Is it clear? Okay. Now for the vertical curves, there are two types of vertical curves. Okay, one is summit curve and another one is valley curve. Summit curve is this type of curve where convexity is upward. Okay, or in terms of your design or structural analysis, you can say like that this is the curve where hogging moment is there. Hogging. Whenever hogging moment is there, in that case, that type of curve is your summit vertical curves, and basically this is your valley curves where convexity is in the downward direction. That is your valley curves. So whenever summit curve and valley curve are constructed, in that case the deviation angle will depending on the gradient of the two section of the road. So we have discussed for the summit curve what are the deviation angles. Now for the valley curve also there are these formulas are given. So for the valley curve, suppose whenever a valley curve is necessary, first let us discuss about it. Suppose a downward gradient of minus n1 and another with a downward portion of minus n2 is meeting each other. So in that case, you have to accommodate both this section of the road with the help of a valley curve. Now here also your deviation angle would be minus n1 minus of n2, that is n2 minus n1. Another one, suppose one downward stream or downward gradient is meet with a gradient of 0, that is n2 of 0. In that case also you can provide a valley curves with your deviation angle of minus n1. Similarly, for this area also you can provide a valley curve with a deviation angle of minus n1 plus n2, and here also your deviation angle will be n2 minus n1. So these are the different types of valley curves which are designed as a vertical profiling of the road. So is this clear? Okay. If it is clear, we can leave the meeting, and our next class will be starting from 1 p.m.